So, when you walk into a big building, say a hospital or maybe a high-rise office, even a concert venue, you're basically relying on this invisible promise, right? That if, God forbid, a fire starts, you'll get warned instantly, and you'll have a clear way out.
Absolutely. That warning, that fire alarm system, it's critical.
Yeah.
But it doesn't just, appear out of nowhere. It's engineered, it's installed, all following some really complex rules.
Yeah. And that's our mission today, isn't it?
Yeah.
We're going to take this pile of regulations, specifically looking at Alberta's framework for fire alarms, and try to break it down, make it make sense.
Exactly. It's a great case study for anyone in safety, engineering, really anyone interested in how these public safety rules actually work on the ground.
How you go from national standards down to local enforcement.
We're cutting through the jargon and the codes to get to 3 basic questions. First, who's actually in charge? Who makes the rules? Who enforces them? Second, when do you have to put a system in? What are those specific triggers? And third, okay, you need a system. But what kind? Single stage? 2-stage? How's that decided?
Right. Let's start with that chain of command then. Who's running the show? Because with specialized codes like this, there are always layers, aren't there? In Alberta, the baseline is the Safety Codes Act. But how does that big provincial law become, the specific wiring diagram for an alarm?
Well, the Act is the backbone, definitely. It set up the Safety Codes Council. Think of them as the main administrative body. They make sure the codes are current, applied right across the province, kind of the central hub.
Okay, but they don't write the technical stuff themselves.
No, they don't author the content from scratch. They lean heavily on the National Research Council, the NRC, and the Canadian Commission on Building and Fire Codes, the CCBFC. These guys produce the national core documents, the National Building Code, NBC, and the National Fire Code, NFC.
Yeah, okay.
Then the Safety Codes Council takes those and creates the Alberta editions. So national recipe, Alberta version.
That makes sense. National standards, provincial flavor. But the actual day-to-day rules, they get pretty specific, right? Based on discipline.
Oh, absolutely. You mentioned layers. We have these sub-councils, 3 key ones for fire alarms.
Because it touches on building, electrical.
And fire safety operations. Exactly. It's a mix. So first you've got the Building Sub-Council. They handle the National Building Code Alberta Edition, or NBC-AE. This covers the design, the device locations, the actual installation, the verification, basically the construction part.
Okay, construction covered, yeah. But it's an electrical system, so.
Precisely. You need electrical oversight. That's the Electrical Sub-Council. They administer the Canadian Electrical Code, the CE Code, all the wiring, the power supplies, junction boxes, making sure the electrical side is safe and reliable. The NBCAE tells you where to put the pull station. The CE Code tells you how to wire it safely.
Right. Important distinction. And the third group, they focus on once the building's up and running.
Yeah, the long haul. That's the Fire Sub-Council. They use the National Fire Code Alberta Edition, the NFCAE. This is all about keeping the system working over time. Regular testing, annual maintenance, inspections, ensuring it's ready when needed.
Okay, so we've got the rule makers and the administrators. What about the actual stuff? The detectors, the horns? You can't just grab any smoke alarm, I assume.
Absolutely not. That's a critical piece. Everything has to be listed. Both the NBCAE and the NFCAE require that all devices, sensors, panels, horns, strobes, everything must be TNULC listed.
Underwriters Laboratories of Canada.
That's the one. They're the independent testing body. They certify that the component meets tough safety standards, and crucially, they publish the standards everyone works to. S524 for installation, S536 for inspection and testing, S537 for verification. These aren't suggestions, they're the minimum requirements.
Okay, last piece of the who puzzle then. Who's the actual person, the entity, on site saying, yep, this passes? The local inspector.
That's what we call the authority. Having jurisdiction, or AHJ. This is your local enforcement. Could be an accredited municipality, maybe a private agency, or a corporation given that power. If you're not in one of those accredited areas, it defaults to the Alberta Safety Codes Authority, ASCA. The AHJ is the one who signs off. They hold the final say, and as we'll see, they have quite a bit of power.
Okay, great. We've got the regulatory map laid out. Now, the big question. When does a building actually need a fire alarm system? It seems to start with figuring out who's inside, right? The risk level?
Exactly. It all hinges on the major occupancy classifications. The code categorizes buildings from Group A through F based on use because, let's face it, the risk in a movie theater is totally different from a prison.
Makes sense. Can you give some examples?
Sure. Group A is assembly. Think theaters, arenas. Lots of people may be unfamiliar with the layout. Group B is maybe the most critical, detention, treatment, or care. Hospitals, prisons, people who can't easily evacuate themselves.
Right. Mobility issues, maybe restrained.
Precisely. Group C is residential apartments, hotels, motels. And Group F is industrial. This gets broken down further by hazard. Division 1 is high hazard, like, say, a distillery handling of flammable liquids.
Okay. So once you know the occupancy, what's the first big trigger for requiring an alarm? Sprinklers seem like a good place to start.
Yeah, that's a major one. If a building has an automatic sprinkler system, you generally need a fire alarm too. The idea is if water flows, something's likely happening, and everyone needs to know immediately.
Are there exceptions?
Just a couple of small ones, like really small systems with fewer than 9 sprinklers on the domestic water supply, or your standard single or two-family house. But otherwise, sprinklers usually mean an alarm is mandatory.
Okay. But now for the really interesting part, I think. The non-sprinklered buildings. What are the hard numbers, the thresholds?
Right, these are the specific lines in the sand from the NBCAE. You must install a system if any of these apply. First, height. Pretty simple. If the building is more than 3 stories tall.
And that includes basement levels.
Yes. Any floor below grade counts as a story for this calculation. Second trigger. Total occupant load for the whole building goes over 300 people.
300 total, got it.
But the third one, this is the one that often catches people. It's not about the total.
It's about where those people are, right? How hard it is to get them out.
Exactly. If the occupant load is more than 150 people either above or below the first story, the code recognizes it's much harder, much riskier to evacuate people from upper floors or deep basements compared to the ground floor. That's a key safety principle.
So 300 total OR 150 above below ground level.
Correct. And then there are a few specific occupancy triggers, too. Any school or childcare facility with an occupant load over 40 needs a system.
40. Okay, that's a pretty low threshold.
Reflects the vulnerability of the occupants.
Right.
And restaurants need one if their load exceeds 150.
Okay, since that occupant load number is so critical, 300 total, 150 above below, how do we actually figure it out? It's not just counting chairs, is it?
No, it's based on the intended use of the space, defined by the code. It assigns a certain number of square meters per person, depending on the activity.
How does that work?
Well, some are straightforward. A fixed seat, like in a theater, is 1 person. A sleeping room in a dwelling unit assumes 2 people. For other areas, it's a formula based on area per person, and it reflects density and risk.
Can you give an example?
Sure. Like, standing space thinks a crowded reception only requires 0.40 square meters per person. They expect people to be packed in. But a classroom needs more space, 1.85 square meters per person, less dense. And an area like a commercial kitchen, generally low occupancy, it requires 9.30 square meters per person. The code basically forces more space in lower risk density areas.
Right, linking space to risk. Now, let's use that famous example from the source material, the 3-story office building, because this really shows how those triggers interact.
Yes, the classic case. So picture this. 3 floors, each one is 800 square meters. And it's office space, so we use the calculation factor of 9.3 square meters per person.
Okay, so 800 square meters divided by 9.3.
Gives you about 87 people per floor. Let's round it to 87.
So 3 floors times 87 people per floor.
Total building load is 261 persons.
Okay, 261. So if someone only looked at that first trigger, the 300 total occupant load, they'd think, okay, we're under 300, no alarm needed.
And they'd be wrong. That's the trap. You have to check the other major trigger.
The load above or below the first story.
Exactly. Here, you've got the second floor with 87 people, plus the third floor with another 87 people.
That's 174 people above the first story.
And 174 is definitely over the 150-person threshold for occupants above or below the first story.
Wow. So even though the total is less than 300, the fact that more than 150 are on upper floors means...
The building must have a fire alarm system. It prioritizes getting those harder to evacuate people warned. It's a crucial detail.
Okay, so we figured out if a system is needed. Now, how does it actually work? How does it alert people? This is where single stage versus 2-stage comes in, right?
Correct. The type of system often depends on that occupancy risk we talked about earlier. A single stage system is straightforward, simple, and immediate.
Full evacuation right away.
Yep. An automatic detector goes off, or someone pulls a manual station. Boom. Loud, audible alarm everywhere simultaneously. Everyone hears it. Everyone gets out now.
Okay. What about 2-stage then? How's that different?
2-stage adds an investigation step. Stage 1 is an audible alert signal. Now, this alert is often coded or distinct, intended mainly for trained staff or building management.
So not general panic yet.
Right. The idea is staff hears the alert, they must immediately go investigate the cause, and very importantly, that initial alert must automatically notify the fire department right away.
Okay, so the fire department is on the way, staff investigates. What happens next?
If they confirm there's a real fire, they manually activate stage 2.
Which is it?
The full, loud, general evacuation alarm, just like the single-stage system.
What if staff are delayed or can't find the source or don't acknowledge the alert signal?
There's a fail-safe. If that stage 1 alert signal isn't acknowledged at the main control panel, usually by staff resetting it or confirming within a set time, typically 5 minutes, the system automatically triggers stage 2, the full evacuation alarm. So safety isn't compromised, but it allows that vital window for confirmation.
Okay, that makes sense. So which buildings have to use which system? Does the code mandate it based on occupancy?
It does, for the extremes. Single stage, immediate evacuation is mandatory for Group F, Division 1 occupancies.
That was the high-hazard industrial, right, like the distillery example.
Exactly. Think places with explosive dust, flammable liquids. If a detector senses something, the risk of it escalating very quickly is just too high. You can't afford a 5-minute delay. Get out now.
Makes total sense.
Yeah.
And the opposite end, where is two-stage mandatory?
2 stages required for almost all Group B occupancies.
The hospitals, the care facilities, detention centers.
Yes, unless it's a very small Group B, Division 3 building, 3 stories or less. But generally, for hospitals, larger care homes, prisons, 2 stage is the rule.
Why the delay there? Seems counterintuitive almost.
It's because of the occupants. Imagine trying to evacuate an entire hospital wing full of patients, some in surgery, some on life support, newborns in incubators.
It would be chaos. And dangerous in itself.
Extremely dangerous. A false alarm, maybe from burnt toast in a kitchen, triggering a full, unnecessary evacuation could be more harmful than the non-existent fire. So the 2-stage system gives trained staff that crucial time to confirm if it's real before initiating a very difficult, potentially risky evacuation of vulnerable people.
Okay, that logic tracks. So F1 high hazard needs immediate single stage. Group B needs the delay of 2-stage. What about everything else? Offices, apartments, theaters.
For most other occupancies, the code allows the owner or designer to choose either single stage or 2-stage based on their operational needs and their own fire safety plan. The mandate is really only for those 2 specific risk profiles.
Got it. Now, installing these systems,
Yeah.
it sounds pretty specialized. This isn't a weekend DIY project, I take it.
Definitely not.
Who's considered qualified? And when does it get complex enough that you absolutely need, say, a professional engineer or architect involved signing off with their stamp?
Well, the rules define a qualified person for the installation work itself. Generally, this means an Alberta electrical journey person, particularly those certified after September 1st, 1991, or some folks certified earlier who've passed a recognized fire alarm-specific course.
Okay, so qualified tradespeople for the install. But the design and verification, when do the professionals, the PE or the registered architect, have to be involved?
The code tries to draw a line based on the building's size and risk. It actually lists specific situations where professional involvement is not required for the design and verification.
Oh, really? So sometimes the qualified installer can handle the design and sign off.
For simpler buildings, yes. If you've got certain occupancies like business, mercantile, or standard industrial, and the building isn't more than 3 stories high, and eats under certain floor area limits, for instance, a single-story office under 500 square meters, then, often, a qualified installer or technician can handle the design and verification aspects without needing separate professional stamps.
So smaller, less complex, lower-risk buildings might avoid that extra layer of professional sign-off.
Potentially, yes, but once you cross those size thresholds, or if you're dealing with a higher-risk occupancy classification—
Like the Group B hospitals we talked about.
Exactly, or complex assembly spaces, high-rises, things like that, then professional involvement becomes mandatory.
And when it is required, what exactly does the engineer or architect have to do?
The code is very clear on this. They have 3 distinct, non-delegable responsibilities. 1, they must design the system. 2, they have to perform field reviews during the installation to make sure their design is actually being built correctly. And 3, they must perform the final verification of the completed system. They are accountable for the whole process, from design through to final acceptance.
Okay, let's recap quickly. We've walked through the who, the whole hierarchy, from national codes down to provincial subcouncils and the local AHJ. We dug into the when, those critical triggers like sprinklers, height, total occupants, and that tricky 150-person rule for floors above or below ground.
Hmm.
And we looked at the why high hazard needs immediate single-stage alarms, while places like hospitals need the two-stage approach for safer, confirmed evacuations. It's quite a system.
It really is. It shows how regulation tries to match the safety measures to the specific risks. But, there's one last really important point about that regulatory change, specifically about the AHJ, the local authority.
Oh, yeah. What's
Even when the code book, the NDCAE, seems to give a clear exemption, like saying this small office building doesn't technically require professional engineering stamps based on size. The local authority having jurisdiction, the AHJ, always retains the right to override that.
really? So they can demand professional involvement even if the code says it's not strictly required.
Absolutely. If the AHJ looks at a specific project and thinks, this system is unusually complex, or these site conditions are tricky, or the way this building is actually going to be used raises concerns, they can step in and say, nope, despite the code exemption for this particular building, we require professional design and verification stamps. They have that ultimate discretion.
That's fascinating. So the code is the minimum standard, but the local enforcer, the AHJ, can always raise the bar based on specific circumstances. Which leaves us with a really interesting question for you, the listener, to think about. How much flexibility should that local AHJ have? If the code provides clear rules, should local interpretation be able to go beyond that text, even if it's in the name of safety? Where's the right balance?
It's a constant tension in regulation, isn't it? Prescriptive rules versus performance-based judgment.
Definitely something to mull over.
Mm.
Well, thank you for guiding us through all that. It's complex but incredibly important stuff.
My pleasure.
Hopefully now when you see those fire alarm devices on the wall, you'll have a better appreciation for the invisible but vital system of rules and checks working behind the scenes to keep you safe.